So, hello everyone. Good morning. Thank you, Sumit, first of all, for such an insightful talk. My name is Farooq Arshed. I'll be giving you the topic of presenting you the topic of reactive programming today. First, a little bit about myself. So, I have around 11 years of experience in the industry, primarily focused on Java and Kotlin. Currently, I'm the technical lead of UAE initiative in Digital Dubai. That is a single sign-on digital identity across UAE. So moving on, the agenda that I'll be following today will be, I'll give you some introduction regarding reactive programming, then why reactive programming, why you should think about reactive programming. And then if we have some time, we'll go over a demo. So moving on, I'd like to know how many of you are Java developers. So only 2, that's good. Okay, so most of you might have heard the buzzword called reactive programming. So what it really is, what do you mean by reactive programming? Let's say from a non-reactive programming, whatever that is. So let's take a look at from the definition from Wikipedia. So Wikipedia states reactive programming as, in computing, reactive programming is a declarative programming paradigm concerned with the data streams and the propagation of change. With this paradigm, it is possible to express static and dynamic data streams with ease and also communicate that an inferred dependency within the associated execution model exists, which facilitates the automatic propagation of the changed data flow. Complex, isn't it, right? So, just to get the understand this definition, you have to read it multiple times just to get the hang of it. So, but anyways, we can extract 3 main points from this definition. One is declarative programming as opposed to imperative programming. The other one would be data streams. And the last one would be propagation of change. So declarative programming is, is a paradigm that tells what to do in your program, as opposed to imperative programming, which tells you how to execute the program by providing step-by-step directions. So declarative programming is like, when you get into a cab, you declare your driver where you want to go. You don't tell him step-by-step directions on how to take the turns to reach to your destination. So imperative programming will be like telling the driver how to reach there by telling him step-by-step directions. Next is data streams. So data streams are streams of data which start somewhere in time and is consumed somewhere else. Also, propagation of change is also related to data stream, that the data that is outputted by the data stream will be propagated to whoever wants to consume that particular piece of data. So now, we can simplify this definition to the following. Reactive programming is a declarative programming paradigm that allows us to asynchronously manipulate streams of data with the help of functions. Moving on, so now let's think about where in real life you can see, some things where action becomes reactive. I can probably give you a few examples, but the easiest one would be to, explain will be user events. So let's say when a user clicks a button on a web application or a mobile application, you have to react to it, right? So it's pretty reactive. So another example would be retrieving data from an API, processing the data, and then reacting to that data or consuming that data in the consumer. So moving on, let's assume that this is a data stream from an API. So I'll be presenting you some exciting dishes today, that will get you prepped up for lunch as well in order to explain data streams. So let's say this API outputs some exciting dishes at any point of time. We don't know when it will output, but we know that it will output the dishes. But our requirement is to only filter past the dishes. We don't want every dish to be consumed at our level, right? So we'll apply some filter function and provide our condition based on our requirements, and then the stream will only filter out past the dishes. So this this data streams can be anywhere. It can be in the cloud, and it can be consumed on let's say a mobile or web application as well. So moving on to the official terminology that we use in reactive programming. So the data stream that I talked about is called as a subject. A subject is a stream that emits data. And the consumer that is consuming that particular data stream is called as an observer. So a single data stream can be consumed by multiple observers as well. So now, these are some more functions that are common in reactive programming. Most of them are pretty straightforward, but I'll go over map and flat map. So map operator, what it basically does is transforms the data into a different data type or a value. What flat map operator does is, it produces a new stream, then apply the transformation, and merges all of them back to a single source. So why reactive programming, right? As server-side backend Java developers, we don't care about user events, right? We are not clicking buttons in our program. So why should, as a backend Java developers, we should care about reactive programming? Keep this question in mind, as the use case that I'll be presenting you forward will relate to this question. So now, as a server-side web development, what we typically do? We typically handle a request, do some processing on it, and then returns a response. That's pretty synchronous, right? Do step 1, 2, and 3, and then return the response. But the user, once user makes a request, he has to wait. He cannot say that, okay, while this request is being processed, let me do something else. That would be another HTTP request. And it will follow the same steps of 1, 2, and 3. So what now we typically do in our modern application development? Nowadays, when we are building an app, we are dealing with huge amounts of data. So now everyone is connected to internet, right? Everyone has mobile phones, everyone is connected to the internet. So everyone can use your application. So your application should meet the need of high data scale. Also now, since everyone is using your application should be highly usable and available. So your application should be able to scale at users' demand. The third one is now cloud computing cost. Now we are concerned about the cost more than ever before. Gone are the days where companies used to buy some servers, rack them up in data centers, and they are done. So typically, what they used to do actually was buy a more configuration in order to spend more money upfront in order to meet the scalability, keeping in mind the scalability of the future. But now, since everything is on the cloud, we are worried about cost more than ever. So let's say a badly written piece of code, which is taking more time to execute, will cost you more in the cloud. And when you bundle it up with high usability, the cost just skyrockets. So now it is more important for us to write optimized code in order to control the cost factor as well. So I'd like you to now take a look at this piece of code actually, and I'd like you to spot a problem. So basically what this code is doing is getting the ingredients of the recipe. Then in the next line, it is getting the steps of the recipe on how to prepare the recipe, and then bundling it up in a recipe object and sending it back. Seems a valid code, right? Particularly, I want you to focus on these two lines. What these two lines are doing. These two lines are calling external database or an API or any service in the cloud to get this data, right? So once a request comes and says get ingredients, now the thread has to wait. The thread has to wait in order for it to return the response. And then only the next call will be executed, right? So once the response comes, then only we are able to get the steps of the recipe. And then we don't know how much time that will take. It will then also block the thread again, and then it will move on. But both of them has no relation to each other. Both of them are independent. Both of them rely on recipe name only, right? So they are kind of unnecessarily synchronous, right? So what was the cost that we paid for them being synchronous. The cost, let's say the first cost that we paid was performance, the performance of our app, right? The request would have reached the end user a bit faster had these been executed in parallel rather than being in synchronous. But let's say we are not worried about a single user request for now. What other costs did we pay? The other cost that we paid was resource utilization. So when a web application server receives a new request, it spawns a new thread, right, to handle that particular request. And if your application is taking time to execute, that thread will remain in the memory. It will consume the resources. And once there will be a time, and then there will be a time when your memory is full of those threads, and you cannot process any new requests since your execution is taking more time to execute. So it is now important that we reduce our execution time as well. Now I'd like you to think about concurrency. When was the last time as a Java backend developers we think about concurrency? We don't think about it anymore, right? Because the frameworks pretty much handles it for us. So we are now only particularly focused in a stateless function that only handles a single request of the user. We don't think about concurrency anymore. So I'll move on to solution. Is reactive programming the solution? Is it the only solution? Since we have a few Java developers here, I assume they are aware about the Java concurrency APIs that was built in Java 8. So future, completable future, these are concurrency APIs that can allow us to execute some tasks in parallel. So next I'll be going over some code, the same code actually, in which I'll be showing you how we can achieve parallel calls using these concurrency APIs. So this is how you execute Java concurrency API parallel calls. So first you supply async will give you a async operation which can be executed in future. Then you have to join the request, and then once the request returns, you will again bundle it up in a recipe object and send it back. But I'd like you to focus on this return type, recipe. It's a concrete object. So this has a problem as well. The thread has to wait in order to return this concrete object. It cannot process the completion without returning a concrete object. So now there's a problem with this as well. The thread has to wait again, right? So now I'll demonstrate how you can achieve the same thing in reactive programming as well. So this is how you achieve the same parallel calls in reactive programming. It's okay if it doesn't, sounds familiar to you. But the first thing that you'll notice is the return type, which has changed to now mono instead of the concrete object of recipe. So what mono does is it is a paradigm that executes only and spits out one data only in future. So what this code is doing is, it is again calling that get ingredient API, zipping it with the procedure API, calling them in parallel, and then bundling up in the recipe object and returning without blocking the thread. So this is more efficient. Now I'll go over some benefits of reactive programming. So in my opinion, reactive programming has a cleaner code, more concise. It is easier to read. That can be subjective, but then it's easier to scale as well. You can pipe in any operators in that. But it provides a better error handling, and then since it's event-driven inspired, it plays well with Apache Kafka, RabbitMQ, etc. Before I conclude, I created this slide actually to let you know how to go about it. So reactive programming has a very steep learning curve. It's once you start to learn, things get quite interesting rather quickly actually. And this needs to click to you. If it doesn't click to you, then you'll be lost. So once you get the hang of it, you'll never want to go back to the traditional way of coding. And the last one is you won't see value in a small project. So reactive programming, you'll see the value once your project scales at large, as I gave the example previously. So this is a demo that I prepared, but since we don't have time, I'll skip over the demo now. This is my contact card if you want to contact, and these are some references. So now I'll hand over to the Buy Now team to present how to, present their topic actually. Thank you, everyone. Thank you for listening.